Alright. Now, up to this point in time, all our reactions we're assuming are 100% yield. Okay? That means we're making it as much as we can. We have so much reactant reacting. And depending upon which one limits our reaction, we're going to make 100% of the product. And we're not going to have anything left over. All the reactant is going to react, and that would be 100% yield. Okay? So when we do the math in class that we've done for the last 2 weeks, and we're asked to find the amount of product, whether it's moles or grams, it's 100% yield. It's theoretical. It's mathematical. We do the calculation. That's the most that we can get out. Okay? An actual yield would be if we would do a reaction and we don't produce as much as the theoretical yield says we can produce. Now, there are reactions that are not 100% yield reactions, and we're not going to get into the chemistry part of it. That goes way beyond what scope that we want to do in here. But the actual yield is actually what's measured in lab. Or if you're in industry and you're doing a reaction in industry, and what you want is the highest percent yield, the conditions that will give you the highest percent yield possible, without putting too much energy into the reaction. Because you say, hey, there's a fine line. Hey, I want to get a high percentage yield, but I'm going to have to maybe increase the temperature of the reaction to do that, and it takes energy to do that. To heat something up, it takes extra energy. So you got to weigh the cost versus how much you're going to get out. Okay? So that's what chemical engineers would probably do. They have to take a look at their conditions, and they have to look at, okay, do I have to add pressure to this reaction? Now, we haven't done much with pressure. Do I have to increase or decrease the temperature of this reaction to get more out of it? Is that going to be possible with the equipment I have, or do I have to upgrade, get better equipment to where I can add more pressure or add more temperature? So we have this thing, actual yield is the amount we actually do produce. So if we take those two values to figure out what's called a percent yield, the percent yield would be this equation right here. So this is what percent yield would be if we would plug in the numbers. Now, if the actual yield and the theoretical yield were the same, then we have 100% yield. And that's ideally what you want. But are you going to get that all the time? In nature and in life, normal reactions, you don't get 100% yield. Very few reactions give you 100% yield overall compared to all the different type of reactions you would have. Your body has reactions it does in it. And your body, though some of those reactions are not going to be 100% yield reactions, they're going to be a lower percentage. So all we're doing is we're bringing that information out to you. Realize that not all reactions are going to be perfect where they make 100% of a product. Okay? Now, we're going to use that equation. In your book, there we're going to go through a couple of setups real quick. It won't take us very long. Page 322 has a couple setups that we're going to do. So go ahead and turn to page 322. 322. We're looking at problems 28, A and B, and 29. By the time we're done doing those, you'll know how to use the percent yield equation better. It's just a ratio. All this is a ratio. All percentages are ratios. Okay, that's all they are. And they give you a percentage. So, like, if I had 20 at-bats in baseball, and I got 10 hits, and the rest of them were, outs by whatever, then I'm getting on base at a 50% ratio. 10 out of 20 is a 50% ratio. In baseball, they call it 500. I'm batting 500. But it's actually 50% of the time I'm getting on. Okay? And so that's just a ratio. So a percentage is just a ratio. You guys know that. Okay? If I have 7% body fat, which would be really good, and I don't have that, probably never will have that again. But that would mean out of 100 pounds, 7 pounds is fat. That's what's called 7% body fat. So it's just a ratio, 7 to 100. Okay? So that's all this is just a ratio. And this yield can be moles or it could be grams. It doesn't matter which one you put in there depending upon what you're given. Okay? So we're going to go ahead and do 28A. It's really easy. 28A asks for what's the percent yield. So we have a theoretical yield of 20 grams and an actual yield of 15 grams. So our equation says 15 grams actual yield divided by 20 grams.
75%.
Right, 75% times 100. 75% yield. Okay, that reaction on that particular characteristics and that tells you that you got 75% of what you theoretically could come up with. Okay? Now, you may have to switch the equation around at times to solve for an actual yield or theoretical yield. So on B, all it's doing is saying, we need for you to solve for the actual yield. So you have what's called 90% equals the actual yield, which we'll just say is X, and then the theoretical yield was 1 gram, is what mathematically says that you could get out of the reaction, times 100. So all we do is get rid of the percent by dividing both sides by 100. So we got 0.9 equals X over 1 gram. So what would be the actual yield? 0.9. See how easy that is? Okay, so the actual yield is 0.9 grams. Questions on that? Pretty easy. This is what you guys do in math probably at different times, or has seen it in here maybe even. Something similar to that setup. Okay? The last question's a little bit more drawn out. What you have to do, and that's a question we'll have to do a little bit more work on. It'll take us about 5 minutes. We'll be done with that. Then you'll get a review out. If you're not done with your worksheet, there's some of you weren't done, you got to finish that up so I can see where you're at on doing these problems and what I need to do on Monday to make your test experience better, because you're getting some more information that that some people are missing. So this is problem number 29. So we're looking at problem 29 in your book on page 322. So we have this equation, and what it asks us on 29 is to find the mass of the PCl5 expected from a reaction where we're starting out with 73.7 grams of PCl free, which is a reactant. And we have excess chlorine. So chlorine's not going to limit our reaction. Okay, it already tells us what's limiting. And this reaction says it makes 83.2% yield. So we're asked to solve for how much could we produce. That's experimental. Okay? So that would be X, or actual, what we're trying to find. Now, on all these problems, you can figure out the theoretical if they give you an amount of a reactant, which they do. 73.7 grams of PCl free. So what we have to do is we've got to solve for the theoretical by doing our math within our equation. So we have to come over here to solve for how many grams, if it was 100% yield, we could produce if it were 100% yield. So why don't you do that? Down here below, I've given you the molar weights. I'll try to do this on the quiz because every little bit of time on the quiz it takes for you to calculate a molar mass, which all of you are very proficient at for the most part, it's going to take time away from the actual problem. So here would be an example. Maybe I would give you some weights. You just have to know how to use them and where to use them. Okay? So go ahead and do the calculation of the theoretical yield with the initial amount of PCl3 given. Okay? Go ahead and do that real quick. Should take you a couple minutes at the most. Okay, so here's what you would do to figure out the weight. You take the 73.7 grams of the PCl3, convert it into moles. So down here's 137.32 of the PCl3 is equal to 1 mole of PCl3. Now we've got it in moles. Next step, do a mole to mole. So 1 mole of PCl3 to 1 mole of PCl5, because that's our ratio that's up in our balanced equation. So we're going 1 to 1. So right now we're here if we would have moles written down below. So then all we have to do is change that mole into grams to get our answer in grams. So we would take 1 mole of PCl5, and up here we put the grams of PCl5. And it's 208.22. Then we do our calculation. Did you guys get an answer of 112? Is that what you got? Okay. So that's what you'd end up with. So that is what's called the theoretical yield. That right there, that 112 is in theory. If we produce 100%, this is theoretical. You can always find theoretical if you're given an amount of a reactant that you can go through and you can solve for the theoretical. All right? So we go back to our setup, which says the percentage that is 83.2% is equal to the actual over the theoretical. Now we know it, it's 112 times 100. So basically we'd have 0.832 equals x over 112. So it's like a setup we did earlier on 28b. So we go ahead and do the calculation, and we get an answer out that is 93.2 grams. So the actual is equal to 92 or 93.2 grams. PCl5. How do I get that? Take 112 times 0.832. Okay, so 83.2% is the yield. The theoretical yield I calculated is 112. This is the actual yield, right? So then I just get rid of 100, percentage, 0.832 equals x over 112. Then I just take it times 112. Okay? You guys should know how to do this. This is math. This is stuff that are just ratios and should be super easy. Okay, once you get it to that point. You don't have to know chemistry here. Okay? You don't have to know any chemistry there. All right? Any questions? Okay. I'm going to go ahead and give you a review out.